So just before I start, I'll just take the attendance and then the coursework. I just want to check that I have everybody's here. So firstly, Mahmoud,
Yes.
Gafar, Amjad, Zara,
Yeah.
Mo, Daniel, Savi, Sabrina, Alfreda, Arya, Chidi, Young Pang, Amna was in the bathroom, yeah. Mariam, oh yeah, she's sick or some GNID or something, wasn't it? Michelle, Abir, Autumn, Celine, Sophia, Mubarak, Shadira, Mohanid, Sabrina, Moza, Angela, Ahmed, Safra, Neil. Guys, why would you mark you absent? Hurry up. Mubarak, yes. And Daniel. Yes. Right, so what I'm going to do now, I'm just going to read out whose coursework I have. So if I call out your name, everything's fine. I got your coursework with the cover sheet and there's no problems, okay? So Mei Xin Lao. Okay, so somebody can let her know everything is okay. Mahmoud,
Here.
I have yours there. Mohanid, no, but you can let him know I got it, okay, it's fine. Mo, I have yours. Mubarak, get off the phone. Off, put it away. Put it properly away, like in your pocket or something. I have your coursework. Sophia, I have your coursework, it's fine. Young Peng, I have yours, and do I have your signature on it? I do. Okay. Zara, I have yours, and I have your signature, so that's fine. Sabrina, I have hers, that's fine. Arya, I have yours, that's fine. Who the heck is this? Oh, that's Gafar. Gafar! Yeah. No, I was just looking at the Abdul part. I'm like, I don't have an Abdul. So I have yours, and it's signed, so that's fine. Abir, yep, that's fine. I have yours. Ahmed, yep, that's okay. Amjad, that's okay. Amna, I should bring it back. I have hers, and it's okay there. Angela, yep. Moza, yep, that's okay. Autumn, yeah, that's okay. I have your signature on it. I think this one is Chiadi. I have, that's fine. And, who's this person? This might be Celine. What's your full name? Yeah, okay, yeah, so that's fine. Yeah. And Chadira is fine. Mariam is fine. And Daniel, right, that's fine. Okay, and there are 3 people. So Neil, not here. When you see her, I can't correct her coursework because she doesn't have a cover sheet, so somebody can tell her. Savi, you're the same. There's no cover sheet on your coursework. Why would you do that? I told you, wasn't I clear? The first page, what did it need to be? The cover sheet. What's wrong? Right, well, no. I still need you to email me, and I want the first page to be the cover sheet. And one of your classmates will help you fix it, okay? But it's important that if your lecturer gives you instructions on submission, you have to do it, okay? So you can email me once you get the back to the front page, okay? And Neil's the same. And Michelle, you're the same. You have to email me with the cover sheet, okay? If I didn't call your name, or you're not one of these 3 non-cover sheet people, then I don't actually have your coursework. Now, perhaps you sent it to me and I didn't get it, or whatever. So don't worry, I called your name, you're fine. Is everybody okay? I called everybody's name. Well, who am I missing who might not be here? I'm missing Mohanid. Did I call Mohanid?
Yes.
Yeah. And Sabrina.
Yeah. Which one?
But did I call two Sabrinas?
No, you.
I did, yeah. Neil's not here, and I mentioned about not having the cover sheet. And then Sabrina, and then Mariam. Where's Mariam? Huh? I called hers, so she's okay. Alright, so that's actually fine then. So that should be okay. And
We solved it in class. Why would people not type it up?
you know, people are just weird sometimes. Like really, just weird sometimes.
What do you mean by everything is okay? Just the cover sheet is there, or
Yeah, I can correct it. Because I can't correct it if there's no cover sheet, you know. And it has to be signed. Or some mark has to be put on your signature. So that's fine. Okay, we'll continue now. Oh no, you don't have to.
Correlation.
Hmm?
Is it correlation?
Yeah, it is correlation time.
I don't know, is it no?
This is what I was thinking.
Now, yeah, correlation now. Okay, so just before we get started, just a couple of more definitions, I'm afraid. So just to recap some we have so far. So big SX, do you remember what that means? It means sum up all the X values, and then big SY would be sum up all the Y values, and then SXX was sum up all the X's squared, and then SYY was sum up all the Y squared, and then the last one we had was SXY, which is sum up the product of X and Y. Okay, just a couple of new ones today. You have small SXY, so small one, and what that means is big S xy over n minus average x average y. So this one here is, it's like, another way to think about it if you want, it's like this. It's the average of x times y minus the average of x and then multiplied by the average of y. It's the difference between the average of the product and then the product of the average. We'll do a yeah. So this small SXY, it's the difference between the average of the product and the product of the averages. So we'll do a calculation example, don't worry.
Is this one of those things where it doesn't make sense in theory but makes sense in solving?
No, I'd say it makes sense in both theory and solving, but that's a difference perhaps. Yeah? The one in the black we've done. Yeah, the red one's new. Yeah. And then small sx is, it is standard deviation of x. So standard, it's kind of like that. So it's square root. Let me see. Yeah, I want to make sure I get it right. Yeah, big S xx over n. So that's the average of x squared. What? Oh, it's sigma. Yeah, I'm just writing s for sum. I'm literally writing this. Minus, and then it's average x squared. In other words, it's a standard deviation of x. And you get the same one for y. Small sy, square root big SYY over n minus average of y squared. Now look, don't worry. The formulas in red are in the formula book. The ones that are in black are not in the book, but I mean they're not really formulas, because they're more like just shorthand. Do you know what I mean? This here is shorthand for Well, what do you think the S stands for? Sum. So it's shorthand for sum of x. And this is shorthand for sum of x squared. And this is shorthand for the sum of the product, yeah, of x times of xy. But the red ones are in the formula book. They're formulas, yeah.
Why does this have a root on it and that doesn't?
Yeah, it's a bit strange, isn't it? That's what the formula is in the book. The S. I assume they didn't make a mistake in the formula book, but it's possible that they did. It does seem a little bit strange that the bottom two have roots and the top one doesn't.
And then it's also very
And they look the same.
I don't know.
Are they?
I don't know. Which ones?
The top and the bottom.
Which ones?
The SX and the SX.
Which one? Give me
The
a
one with the red
sentence.
and the one
No, no. Your question should
The
be.
first
No,
one.
no, no, no. Your question should be: Teacher, is blank the same as blank? And you can fill in the blank. So the blank could be: Is SX the same as SY? Okay, so I'm gonna try again.
Okay, is SX is the one in black the same as the SX as the one in
No, it's not, because this is a big S and that's a small s, which is what I said.
That doesn't differentiate it that much.
Well, it'll be a little bit easier in your notebook, because in your notebook you'll have lines to write on. So you could write a big S or a small s. Yeah.
Do you need to memorize the formula for the best fit?
I'm getting to that now. Okay. Anyways, Angela, actually, you know what? I'll check that out for you, because it does look peculiar. I did check the formula book before this class just to make sure these red ones are in the book, and they are. And it is a little bit odd that that product one doesn't have a root, whereas the other two do have it. So I'll see if there's a reason for that, actually.
It's because, like, you can think of x and y as squared. Yeah.
Maybe, but I'm not convinced.
But then there's x squared there.
Yeah.
No, but the other ones, if you look at sx is equal to, over there it's sx and y, so it's basically squared. So if you want sx, then you would have to square it. Makes sense.
Okay, if it makes sense to you, I'm happy for you. Continuing. Now, you recall the last time I gave you formulas for A and B, for calculating the A and the B in the line of best fit. Now that's fine. You can use that formula in the exam. But if you're like me and you can't memorize things, then there is another formula which you can use in the formula book. The formula in the formula book uses small s's. So I'll give you that formula which is in the formula book. We can actually kind of work it out. So you want to find the equation of the best fitting line. So we might have seen this formula, or you might have seen this in school before. It's y minus y1 equals m times x minus x1. Okay? Now, where x1, y1 is a point on the line. There is one point, now think before you answer, I said this to you last time. There is one point that you are guaranteed to be on the line. What point is that? The average. So already we're halfway finished. We have y minus y bar equals m times x minus x bar. So the only thing that's left to find is what the slope of this line is. And that's in the formula book. The formula for the slope, it's not y2 minus y1 over x2 minus x1, because there could only be one point on the line. The formula uses small s's. So it's small s xy over small sx squared. And that is in the formula book. This is in the formula book, and these three are in the formula book. Again, you can use the formula we did last time. There's a good chance you'll have trouble remembering it, and if you do, you can do this. Now, each formula has an advantage and a disadvantage, okay? The advantage of the formula I gave you last time is you get the answer directly and instantly. But it's harder to remember. The advantage of this formula is it's easier to remember. It's in the formula book. However, after you get it, you have to rearrange it a little bit. You know, bring the y's to one side, the x's to the, you know, like for example, you'll have to expand this, and then you'll have to bring this over to the other side. So it's not quite as instant as the first formula. So there's a balance between the two. You can either have the answer directly, but harder to remember, or you can have it easier to remember and do, but a little bit more steps. It's up to you. Yeah.
In the second formula, the one in black, the one in the middle, not in the square.
Yeah.
The y minus y.
This one?
No.
This one?
The one
This
in the middle,
one?
not in the square.
Not in the square. This one?
Yeah.
Yeah.
So by m you mean the slope.
Yeah.
By x you mean any x point that was given to us. By
X1.
No, the one under it.
X here.
Yeah.
No, this is just variable x. It has no particular value.
But couldn't we just plug in the values from the data set that we have?
No, because you don't know if the points are on the line. It's entirely possible that all the points are off the line.
Yeah.
It could be like this.
The only point is the average.
Yeah, you're only guaranteed that the average is on the line. That's the only guaranteed point on the line. Yeah?
The s small s squared,
Yeah.
is it the sum? The s
No, these are both small, okay?
is it the x square of the sx we found there, or square of the x's?
No. This is your answer and you square it. If I meant x squared, I would have written sxx to prevent confusion.
What's that slide for? Something else, or we're just not going to use it?
Oh, we'll use that today. I haven't given you the formula yet. So I'll just do a very, very quick example just to demonstrate this, okay? We'll just do an example with just 3 points to keep it short. So here's my data, here's my x, and here's my y. And we'll just do 1, 2, 3. So we'll keep the x simple, 1, 2, 3, and we'll keep the y simple, say 1, 4, 9 as the y's. So if I graph it, it'll look like this, and I think my line will be something like that. Let's calculate it. So firstly, it's y minus the average of y. So 9 plus 14 divided by 3. What's that? 14 divided by 3 is 4.67. 667.
Yeah.
Equals, we'll have to calculate the m, and then x minus 2. Okay? But we still need to get the m. Right, let's calculate the m now. And you should write this example down. The m is equal to, right, on the top is sxy. So do you remember the formula here? It is right here. You get the product and add them all up. So it's 1, can you type this in as I'm going? 1 plus 8 plus 27. What's that?
36.
Divided by 3? 12, exact?
Yes.
Nice. Then minus the average x, which we've worked out, times the... that's the average y. Well, it doesn't matter which way, because it's multiplication. You multiply the average x and the average y. Okay? Now, what goes down below? It's sx squared. So it's going to be squared. And the square and the square root cancel. When you square this, the square root cancels. It's going to be sx squared. So on the bottom is minus average x, which is 2 squared, which is 4. And then sxx over 3. So that will be 1 plus 4 plus 9 is 14, isn't it? 14 over 3 is 4.667. Coincidentally, the same number. Right, so what does this equal, please?
2.666.
2.66?
Yeah.
Ah, come on.
I got 3.997.
I need a third person to break the tie.
3.997.
Oh no, 2 times now. 3 point.
997.
You didn't divide it by this number.
Oh.
Ah, thank you.
You want that
3.99. So it probably actually rounded off to 4 because of the rounding here. So the answer is y minus 4.667 equals 4x minus 8 when you multiply the 4 in. So can you just do minus 8 plus 4.667, please? What you get? 4x plus,
Give me mine.
oh sorry, minus 3 and a third, is it?
3.33.
Okay. That's the answer.
There's one more 3.
I'm 3 significant figures.
Where did the 12 come
The 12 was the product added up. Yeah. It's only 3:30, Mark.
I'm sure, yeah, but you know,
Close enough?
the teachers who are really efficient at this
Ah,
stuff.
okay. I'm not so efficient.
That's the noodles are going out of fashion.
I was stock?
Well, no, they're not out of stock, but there's only half of what was there yesterday.
Better stock up. Thank
Well,
you.
that's the case. See, guys, yeah, if you work really hard, you can go home early too.
I might let them off at 4 o'clock.
Would that be nice?
We finish at 3:50.
Who wants to stay until 4:30?
Good students.
That's that easy, isn't it? Good students want to stay.
They do. Right. So, as I was saying, the disadvantage of this formula is that you see it takes you more steps to get to the answer. Whereas if you use the formula we did last time for the A and the B, you can get these answers directly. So if you really want to avoid this, you'll have to learn those other formulas, okay? But if you don't want to do that, then you have this formula that gives you the same answer in the formula book. Okay, question? No, continue? It's literally just using the formula. There's no thinking to it. Question, guys? Guys, question? Chitty chat girls, question?
Can I go to Rod End?
Huh?
Go to Rod End?
No.
Please.
Shh, quiet, you're annoying me. I'll do one more example, but no, actually, you didn't write anything down, so I'm not going to go through it again. Yes.
The 2, 4, 6, 6, 7,
Yeah. The 2 and they're the average of x and y, yeah. I'll do one more example, but not for you, because you're not making notes, so.
I thought we went through this before. I look at the videos and all the notes that are.
No, just getting more annoyed as you talk more. Yeah, there we go.
Sir?
Yeah?
So the formula is m is equal to.
I'm going to do another example. I'll do another example. But I want everyone to take out their calculator so we can do it together, okay? Right, scrolling down. Okay. So look, I'll keep it simple. I'll just do 3 numbers to save time. X, Y, and we'll say 1, 3, 5, and then we'll say 2, 4, 5, like that. Okay? Right, so please pay attention. The first thing you should do is calculate the average x. You all know how to do that. 3 plus 5 plus 1 over 3, I believe you'll get 3 as the answer. Let's calculate the average y. It's 2 plus 4 plus 5 is 11. 11 over 3 is what?
7.666.
3.6,
7.
okay.
What?
It's 7.6.
7.
11 over 3? Come on, this is the first step. 11 over 3.
3.6.
Yeah, okay, fine. Fine. Okay, now, the next thing we should do is calculate SXY. So that's the product, the average product. So it's 1 times 2 plus 3 times 4 plus 5 times 5 over 3 minus the average x times the average y. So what do we get here?
You get 1.999.
Yeah.
1.99, so basically 2 then.
Yeah.
Okay, 2. Right. The next thing you need to calculate is Sx squared, which is the average of the x squared, so that's 1 plus 9 plus 25 over 3 minus 9. It was 3 squared.
2.66.
Okay, it's like that.
Oh, you just remove the root because it's square.
Yeah, exactly. Right? So the formula is, for the equation of the line, y minus 3.667, and the m, remember the m is this divided by this, so that's 2 over 2.667 times x minus the average x, which is 3. So what is 2 over that, please? We'll simplify it.
It is 0.7499.
3/4 then.
Oh,
2.75.
Yeah, 3/4. X minus 3. So if I expand, what do I get? 0.75x minus,
2.249.
so 2 1/4. Yeah.
2.25.
Yeah, yeah. So finally, y, oh sorry, I lost my x there. Y equals 0.75x plus 3.667 minus 2.25. What's that, please?
That is, that's 1.417.
1.417. Like this. So that's 1.42 if we
Yeah.
round it off. That's the equation of the line. That's the exact same answer you would get if you used the formula for A and B that I gave you. So you see there's nothing to it, it's just using the formulas. All these are in the formula book. Okay?
And
Sir, is it okay?
No, listen. This formula I used here is in the formula book. This is in the formula book, and this is in the formula book, and these are obvious. Okay, go. What's...
Is it okay to round so much?
Well, I think when you're doing your calculations, you should be a little bit more than what I'm doing. No, actually, I'm all right. At least 4 significant figures for calculations, and 3 for the answer. Yeah.
What if we put this formula from the formula sheet and we'll take the same?
I'm still speaking English, haven't I? What did I say the formulas were? Where are the formulas in the formula book?
yes.
Yes. How many times have I said that? Roughly.
I think the same thing.
Roughly, how many times have I said that? 4 or 5 times perhaps? Okay, okay. Next person who asks me, well, you don't want to know what I'm going to do. Right, continuing. So, back to actually what I wanted to do now. Correlation. I'm sorry, oh wait, before I scroll down. Do you all have that written down? You need a minute? Okay.
Okay, so I have a question. Would
Now
they-
please, you're not going to ask me are these in the formula book.
I didn't.
Make it a good question, otherwise I'm going to start taking your question privileges away. Go on.
Okay, so would they ask us to find the equation of the line and then draw
So far it's a bad question, keep going.
and then draw it precisely? Like we would have to use this to get the data set and then graph it.
They could do that. Although they don't usually. Usually it's the other way around. No,
What? How would it
no,
be
usually they ask you to draw it, draw the line in roughly, and then calculate precisely. Yeah.
But how would they know that they didn't calculate and then?
They don't. So some students do that actually. I've seen it. I can tell when students have done that. So you can do that if you like. Like I said before, sometimes in the exam, you don't. It might be easier to do the next part first, depending on what's happening.
It seems to be in more of a chronological order if it was you find the equation of the line and then you get.
Okay, that's not a question, so I'm not going to answer it.
But doesn't it make more sense?
Oh, that's my personal opinion, so that's I'm not going to answer that either. No. Okay,
Is it in
continuing.
the formula book?
Don't. Don't. Dude, I'll stuff that red cap in your mouth. Okay. Right, so here, which is a, Sakura, come on. Which is a better fit in line? So you can have something that looks like this, and maybe a couple of them are even on the line, and you could have something that looks perhaps like this. So obviously we get a feeling that the first one is a better fit, and the reason for that is because the residuals are smaller than here. You get smaller residuals. There is actually a way to calculate how good of a fit it is, and that's using something called correlation, which is actually what we're doing today. And the letter that represents that is OR, and it takes a value between -1 and 1. And here's the interpretation. So I'll draw some examples. I'll do well, at least 4 examples. Maybe I'll do 6 then. So if OR was equal to -1, what that means is that all your points line perfectly on a downward line. Okay? If OR is equal, so that's -1. If OR is equal to +1, it means all your points line perfectly on a upward line. If OR was 0, it means your points appear to be random, and any line that you've drawn, it really could be anything. Okay, so this is 0. Now values in between are a little bit more difficult. So a value of 0.8 or greater, that's when the points really start to look like they're on a straight line. So that might be 0.8. And likewise for -0.8. 0.5 is still okay, not great, but maybe it's more like this. And say 0.25, really the line is only roughly there, so it might be like something like this. You can kind of see a line, but it's not great. This might be like 0.25. Now in the exam, what's the typical question is, they would give you some values of OR, and they would give you some graphs, and then you have to match them up. It'll be pretty obvious, you know, they won't say like 0.5 and 0.6. It'll be extreme, like it'll be a 0.2 and a 0.9. So it's kind of easy to see which is the better fit. Okay? So you should draw these as some examples, and then we'll see how we can calculate this correlation. So if you can just draw those as examples. Guys, we're chit-chatting. Have you drawn this? Have you drawn? Do you really make notes afterwards?
No, I don't make notes. I go watch a video.
So you make 0 notes?
Yeah.
That's bad.
I just solve questions.
That's bad. Oh, you solve questions?
Yeah, I just
Okay,
solve
fine.
the questions.
Still, no notes? That's bad. Makes me sad. Makes me sad.
Why do you care? It's the way I sound.
Why would I care? Yes, I'm just your maths teacher. Why would I care if you make notes? Not true.
If
No,
my
no,
notes are
no, no,
fine, if it's working for you.
Okay. Okay. Right, got that? Got that, guys? Yeah. Okay. So how can we calculate this OR? Formula is also, the formula is in the formula book, and it is small s xy over small sx small sy. These are all small. Okay. So you were asking me earlier, do we not need the SY one? So we do now for this one.
That's small x repeats.
Oh, I'm glad this day is nearly over.
Is it in the corridor?
Right. I'll scroll back to the example we did earlier to calculate. So let's go back to the last one you did, which was, where is it gone? Here. This one here. The reason I'm picking this one is because we already have it partly calculated. I'm just going to very roughly draw it first, and we'll just try and estimate the answer before we calculate it. So a rough sketch here. How big do I go on the x-axis and the y-axis? So I need to go up to 5, isn't it? 1, 2, 3, 4, 5. And on the y, it's also up to 5. 1, 2, 3, 4, 5. So my first point is 1, 2, which is here. My next one is 4, 3, and the last one is 5, 5. So if I was to draw the best fitting line here, it'd probably be something like that, roughly. So I don't know, I'm thinking that's decent enough. I would say that's maybe like, my guess is R is equal to maybe 0.7, I guess. Let's calculate and see what we get. So on the top, what's on the top of my formula? I said it was xy, which we calculated already, didn't we? What was it?
2.
Was it 2?
Yeah. It's right
Exactly 2. Yeah, okay, great. Now just be careful, it's not sx squared, it's sx. What did we get for sx squared?
there. 2.6.
We got 2.667. So I need to have the root of 2.667, and I haven't calculated the sy one yet. So let's calculate that. It's going to be 2 plus 4 plus 5, or 2 squared plus 4 squared plus 5 squared. What's that? 4 plus 16 plus 25, please.
That is
45.
45.
Divided by 3.
That's 15.
Exact?
Yeah.
Nice. And then minus the average of y squared. Where is the average of y squared? 3.667 squared. All right. So what's that for the correlation here?
That's 1 point.
The whole, no, the whole thing. Give me the whole thing.
1.25.
The whole thing? Yeah.
So radical that's 1.
No, look at what I have on the screen. I want the whole blue fraction, please.
0.9.
It's that high, is it? Yeah. No. That, if it's that high, it's fine. So my. Okay, so it's actually much better than my estimate. So it's a high value, much higher than I thought. 0.988, and then, okay, so rounds to 988 then. 983? Okay. If you round it off. Yep. Yeah. No, impossible. It has to fall between -1 and 1. It could be 1 or -1, but it can't fall outside that. Yeah. Now, the last thing to look at is the interpretation. So, obviously, because this value is near 1, we can say that the data points and the line match very well. And because it's positive and not negative, what else do we know? It's upward sloping. So, if they ask you to interpret this result, there's 2 interpretations. The first one is 0.998 is nearly 1. Therefore, the line fits very well, nearly perfectly, and has a positive slope.
So if it was minus 9.9.
Yeah, the only difference is it's a negative slope.
But it would also be fitting very close.
Yeah,
And if we get anything above 1 or -1, that's completely wrong.
completely, unimaginably wrong.
Because I got 1.1.
Yeah, completely unimaginably wrong. Right, and I said there's a second interpretation here. Did you write this down? You get a mark for this in the exam. They're going to say, interpret this result. Do you need to write some sentence? You have this sentence? Suppose the answer was something like 0.2. Then you would say 0.2 is nearly 0, so it's not a good fit at all. In fact, it's nearly random. There's almost no line. It's just scattered points. There is a second interpretation, and there's actually a meaning to what R squared is. So what is this number squared, please?
0.965.
Yeah.
966. Now, R squared, you can see, is between 0 and 1, obviously, because you're squaring it, it's positive. What you can normally do with the R squared is change it into... Daniel, you're distracting me with your flipping peanuts. Are you listening? Okay. The R squared is 0.966, and what you do is you change this into a percentage, which is 96.6%. And the interpretation of this percentage is, this is how much of the data's variance you've explained. So I'll explain what that means now, but I'll just write it down for you. So you could also say the linear model has explained 96.6 of the variance. Now I'll explain what that means in a moment, if you just want to write that down. I'll just draw that again. Okay? Let me explain what that means. So at the beginning, before I produce any line, I know absolutely nothing about the relationship between x and y. I have no explanation for y is the value it is and x is the value it is. I don't know anything about them. The moment I draw a straight line, I'm trying to offer some explanation. Guys, pretend like I'm giving you information important for the exam. Because like I said, there'll be 1 mark for a sentence like this and 1 mark for a sentence like this. So I'll start again. At the beginning, we have no relationship between the x and the y. We don't know why the x and the y have the values that they do. The moment I draw a straight line, I'm trying to explain that. I'm trying to say, well, y is this value because x is this value. However, I haven't done a perfect job because there's a little bit of a residual here that is unexplained. This line is explained in 96.6%. So what that means is there's still a little bit of explaining to do. So perhaps, now we won't do this, but as an example, perhaps you might decide rather than fit in a straight line, perhaps you should try to fit a quadratic. Now perhaps the quadratic fits a little bit better, but there's still maybe a small variance here. If my R squared was 99%, what is happening is you are doing a better explanation for the relationship between x and y. You've explained 99%. The only time you get a 100% explanation is if you can find a model that fits all the points perfectly. Then you've actually explained 100% of everything. Okay? So you have 2 approaches you can take. You can either explain by looking at what the R is, or you can explain by looking at what the R squared is. Each of them has an interpretation. In the exam, they tend to prefer you explaining by using the R, but there is nothing wrong with explaining by using the R squared. Question, yeah?
Would they use it in an exponential question?
No, we only concern ourselves with linear. Yeah. Yeah.
2 questions.
Yes.
One of them follows up on what
Yes.
Musa says, but I'll ask it later. Do we have to put in both, or would one be enough for the answers? Would
One's
it be-
enough. One's enough, yeah.
Okay. The
Oh no, both is overkill. Just one. Yeah. Okay.
Second question is, if you would go back to where we had y minus average of y is equal
Yes,
to m minus
yes, yes,
yeah,
yes.
that formula. Is it possible to solve it and find like an exponential or a quadratic or a cubic? Based on what you said, that's possible.
Yeah, but not for us. We only do it linear. We're only doing linear. So you don't have to worry about that. But it is possible at third level, you know. Linear models are too simple for further studies because most relationships aren't linear, you know. Like you know this from biology, don't you? The relationship is not linear. It's linear and then it levels off. Okay. So the only reason you're studying this as an introduction, but when you go on to study further, you look at other possible models like fit in a curve which tapers off. It's only an introduction to the concept. But even though it's a different problem, you still use the same language of R squared. So that's why you're doing this now, to introduce you to this language that you'll see again when you look at further statistics and research. Okay? Now, the thing about these lessons are, it's all just calculations using the formula. You really want to practice getting it done quickly because, you know, it takes time. You don't want to be wasting your time in the exam and then realise you've mistyped something, okay? So, you know, it's important that you practice doing some of these. Just so you know, in question 1, you see there A, B, C, and D, they're all big S's. Okay? I just want to add in a couple more. Can you just add in H-I-J? Just handwrite them in, please. So, as an extra trick, now you do have to write this because this isn't a note. I'm instructing you, I'm giving you extra questions. So, in question 1, after G, write H-I-J. And for H, I want you to calculate small sx. For I, small sy. And then for J, small sxy. And if you want to flick at the back, I'll actually give you the 3 answers so you can check that you've done them correctly. So the 3 answers would be, for the first one, it would be, do I actually have? Yeah, 3.74. The next answer would be 9.25. And the last answer you should get is 93851.47.
Could you go over
Again, please.
Huh? Which one?
Last one.
93851.47.
what about I? One just before.
Which one?
I. The middle one.
9.25.
You see, this is hard to do.
Yes. I've said it twice. I'm not going to. No. I'm not going to say 3 times. Ask a classmate. I have to limit myself at some point.
Is it in the form?
Can you just like? Is it inappropriate to ask students to beat up a student after class?
Trust me, sir, I'm just almost as annoyed.
Oh, I see.
Sorry. It's small x.
You make too much noise, man.
Oh,
Trying to
It's
concentrate.
the standard deviation.
Yeah, Sx is like the standard deviation of x.
It is, or
Oh, sorry. Okay, it is.